All right, let's discuss graphing exponential functions. So I'm making this video separate from looking at just a general exponential function because I think there's some value in just spending some time looking at what the graph looks like and not worrying too much about the mechanics of how we got there. And I kind of want to focus on comparing it to polynomials just because we spend a lot of time graphing polynomials, and so hopefully using the same strategy will show you guys that really it's not anything that's too new, and actually it's a lot simpler than graphing polynomials. So hopefully that is encouraging. So hopefully you'll recall that when we were graphing polynomials, I would have you guys, whether you did it or not, I was hoping that you guys would do a table. And the reason that I like tables is because it gives you a place to kind of organize your thinking. So I know that for me, it's tough to store a lot of numbers in my head. I like to write them down so that I can go back and reference them. And I think that's generally true for a lot of you guys, that it's tough to take a lot of numbers and store them in your head. So having a way to write those down in a way that's organized and a way that I can go back and reference those is valuable. So what we would do is we would have this x and y table. So I want to check certain x values, and I would get out certain y values, right? So usually we did -2, -1, 0, 1, and 2, right? So I'm checking 5 x values, and if you look at a graph, those values are kind of centered around the origin. So what we're getting is whatever our graph's doing in this area, right? We don't necessarily know what that is, but hopefully by graphing these 5 points, we can start to get a picture of what our graph looks like, and then we can kind of guess at what's happening outside of there, because usually there's a pattern or a direction that it's going, and it becomes relatively obvious to us what it's going to be, right? So let's say that this blue graph here is represented by my function f of x, and I'm not even going to give it's equal to something, but we don't really care about that a whole lot. We just want to know what we're doing, right? And so when I'm plugging in an x value and using function notation, that's f of x there, when I plug in -2, what I'm finding out is the y value of my graph at an x value of -2. So I'm saying, okay, I'm at -2. Let's do a different color. I'm at -2, and then I want to figure out where my y value is. So am I going to go up, I don't know, 5 units, and my point's going to be there? Or am I going to go down 5 units, and it's down here? Or anywhere, so long as my x coordinate is -2, right? If I plug in -2, then I get out that y value. Another way to write that is my function f evaluated at -2, and that gives us out some value. Well, if I do that for all 5 of these values, then I get out a set of coordinates, and I can graph those 5 points and then connect them from left to right and get a picture of what my graph looks like, right? So here you would plot the points here, here, and then you would draw through them, right? And maybe not everybody's picture looks exactly the same, but at the end of the day, we have the general shape. We know that it started above the x-axis, it went down below, it turned around and came back up, and if you plotted those 5 points correctly, then you're going to get something like that. Whether it looks exactly like the graph or not, that's not the biggest deal in the world, especially considering that I doubt that many of you guys have any interest in being mathematicians. What do you care if you know exactly what the graph looks like? What's valuable is being able to look at it and say, okay, well, it went down below the x-axis for a little bit, and if you were given a problem, then you might, be able to say, oh, well, that means that something was decreasing for this period of time. And that's really why we look at graphs, is because it allows us to generally say, okay, well, here's what's happening between this time period and this time period. Or if I have, if I'm investing this many dollars and it's growing at this rate, how many years before I get to this number that I need to retire at, or something like that, right? It doesn't have to be this perfect graph, but we do have to be able to make inferences off of it, and pull out certain amounts of data, right? So that's why we spend so much time on graphing, because it's a way that the world likes to communicate data, and it's a way that you're going to see data no matter what field you go into. In whether it's in your personal finance or in your line of work, you're going to see graphs. And so it's important for us to be able to, one, build graphs so that, two, we can understand how they work. All right, so let's look specifically at exponential functions. So an exponential function is just like an exponent. So if I said, I want to take 2 to the second, you'd say the 2 is being raised to the second power, right? The second power is the exponent there. And then maybe I'd do 2 to the third, and 2 to the fourth, and 2 to the fifth. Alternatively, I could just write this as a function. I could say, well, I want to look at 2 raised to a lot of different powers, so let's just look at 2 raised to the x, okay? And x is just wherever I am on my x-axis. So if I'm at 0, then what's 2 to the 0th power? And if I'm at 1, what's 2 to the first power? And what I get out is my y value, and what I put in is my x value, right? So just like we did with polynomials, let's build a table and start to look at a graph. Right. Because a lot of what happens with our graph happens in that middle area, I'm going to do the same values. We're going to do -2, -1, 0, 1, and 2. Right, and hopefully that's going to give us a nice picture of what our graph looks like. So first, I'm going to plug them into f of x. So f of -2 is 2 raised to the x. Well, x that I'm plugging in is -2, 2 to the -2. Now, if you remember, if you are not well-versed in your negative exponents, I have a video up on my Google Classroom for you guys to check out, or I just recover that. So if you don't remember it, that's fine, but I would go back and check that. But what happens is when we have a negative exponent, what's in the numerator gets sent to the denominator. So it's secretly 2 over 1, right? So the 2 goes to the denominator, the 1 goes to the numerator, and the exponent becomes positive. Well, 1/2 squared is 1/2 times 1/2, which is 1/4, or if you hate fractions, 0.25. All right, so I'm going to say 1/4 or 0.25. Okay, so that's one value. Now, the efficient way to go about this would probably just be to plug them into a calculator. I'm doing them by hand now because I think it's useful for us to know how to operate with them. So I want you guys to be able to see how I'm operating with the exponentials. But once you're comfortable with that, the efficient way would just be to use a calculator and plug them in. So x evaluating at -1, I've got 2 raised to the -1. Well, 2 raised to the -1, I flip the numerator to then the denominator. That's 1/2 raised to the first power, which is just 1/2, or 0.5. Okay. Next, 0. I've got 2 raised to the x I'm evaluating at 0, so 2 to the 0. Anything raised to the 0th power, no matter how big or how small, is always just equal to 1. So f of 0 is 1. F of 1 is 2 to the first, which hopefully we're starting to get a little more comfortable as we come into the positives. 2 to the first is just 2. And 2 to the second, 2 times 2 is 4. So now what I have is a set of coordinate pairs. All right, so if you're not seeing them, then it's x and y, x and y, x and y. And now I've got 5 points, so let's try and graph those. So do that, I'm just going to give us, and all we're looking for is a rough sketch, right? It doesn't have to be pretty. I just want to get an idea of what this graph's doing, okay? So we've got -1, -2, +1, +2, and then hopefully after we've graphed these 5 points, we can kind of get an idea of what our graph looks like, right? So first point is -2 1/4, so let's put that right above the axis there. Next point, -1 1/2. Well, it's slightly above 1/4, right? 1/2 is bigger than 1/4, so it should be slightly above. So we'll put it there. Next, next we've got 0 1. So I'm at 0x. I go up to 1, 1 2, and 2 4. So now if we trace through these points, you can see that my graph is clearly getting bigger, and it's starting to get bigger quicker. And if I wanted to extend this out like we do with our polynomials, well, what do I think is going to happen? I think on the right side, it's going to continue to go up. And I think on the left side, it's probably going to continue to go down. Right, but it seems like it's getting smaller and smaller, so I expect that it would continue to do that. Right, and so what happened, all I did was I plotted 5 points, I got a picture of the graph, and I got this picture of an exponential. A lot of this is going to be covered in another video, but just for a little bit of a teaser, really that's as complicated as exponential graphing gets. Right, with polynomials we had a bunch of twists and turns in the middle, and that's great, that's cool, and it's perfect for modeling many things. But with exponentials, they're remarkably simple. They are going to generally look like this, whether they're a little bit steeper or less steep, or maybe they're the other direction, which we'll talk about later as well. But there's no extra turns, there's nothing like that. It's going to pass through the x-axis at 1, pass through the y-axis at 1, and other than that, it's not super exciting. So the nice thing is that it's relatively simple, and we'll spend some more time on it in another video. I just wanted to start by looking at graphing. So as always, if you have any questions, feel free to send me an email. Otherwise, hope you guys are doing well, and I miss you all.